good afternoon. In the previous lecture, we seen that the theorem a group G is solvable if and only if the nth derived subgroup of G is equal to singleton E. Okay. So alternative statement for this theorem is a group G is solvable if and only if we have the normal series with abelian factor. Okay. The proof of this theorem we seen in the last lecture. Okay. Now the next theorem is the subgroup of the solvable group is solvable. Okay. What is the next term? The subgroup of solvable group is solvable. The next theorem is subgroup of solvable group is solvable. Okay, what is the meaning of this statement? If suppose this is the group G and this one is the H, and H is what? Subgroup of G. Okay, and G is solvable. Then we have to show that this H is also solvable. Okay, that means the G raised to N is equal to E if then H raised to M is also equal to singleton. Okay, so in the last lecture we proved that if G raised to nth derived subgroup of G is equal to singleton E, then G is solvable. Okay, that means there exists a sequence H naught is normal in H1n is normal in up to so on Hn is equal to G with abelian factor. Okay, H2 upon H1 is abelian factor. लक्षात आहे ना? Okay, so
Yes, sir.
here we have to do that this H is also solvable. Okay, we have to show. Wait a minute. Proof. Suppose H is the any subgroup of solvable group. Suppose this capital H is any subgroup of solvable group G. Solvable group capital G. That means suppose this one is G, it's solvable, and this H is the any subgroup of G. Okay, so let what is G is solvable, that is G raised to N, that is nth derived subgroup of G is equal to what? Singleton E, which is contained in G raised to N minus 1, that is nth derived nth minus 1th derived subgroup of G, which is contained in up to so on G2, second derived subgroup of G, first derived subgroup of G, okay, which is contained in G0, which is equal to G. Any doubt up to here?
No, sir.
No, sir.
Okay. जसा जसा derived subgroup आपण घेत जातो तसा छोटा होत जातो. Okay, so here if nth derived subgroup of G is equal to singleton E, that means G is solvable. So here the G is solvable is given to us. That means there exists a sequence like this one. Okay, be the solvable series, and the series is known as solvable series for G. Okay, and we have to prove that H intersection G raised to N. Okay, H intersection with G raised to N, nth derived subgroup of G. Now tell me, what is the intersection of this one? What is G raised to N? Singleton E. Okay, याच्यातला छोटा कोण आहे मग? H आणि G raised to N मध्ये? That is singleton E. Is it correct?
Yes, sir.
Intersection of H and G raised to N, which is contained in H intersection nth minus 1th derived subgroup of G. Okay, ह्याचा प्रत्येकाचा एलिमेंट हा प्रत्येक एलिमेंट काय घेतला H सोबत इंटरसेक्शन घेतलाय up to so on, which is contained in H intersection second derived subgroup of G. Okay, which is contained in H intersection G dash, that is first derived subgroup of G. Okay, and this is contained in G naught. Okay, that is H intersection G naught. Okay, and which is equal to H naught. So now the left one H naught, which is equal to what is G? G naught. What is G naught? G naught is equal to G naught. So G intersection H is what? G intersection H.
H.
H. Very good. H naught is equal to H. Okay, is the solvable series for capital H. Okay, give it as an equation number one. This one. Okay, any doubt? This is G,
No, sir.
which is equal to singleton E G raised to n minus 1. Okay, contained in G raised to n minus 1, which is contained in up to so on G. ओके आणि एच साठी आपल्याला एक सिरीज सॉल्वेबल सिरीज एक्झिस्ट होती ही दाखवायची ती सिरीज कोणती असेल तर ही सिरीज असेल ओके ओके एच आणि एच इंटरसेक्शन जी रेस टू एन ह्याच्यात लहान कोण आहे विच वन इज स्मॉलर कोण कोणात कंटेंट असेल हा ह्याच्यात कंटेंट असेल ओके हा इंटरसेक्शन घेतला याच्यासोबत ओके नो टेल मी H intersection G raised to n minus 1. That is n minus 1th derived subgroup of G intersection of G. Intersection of H is contained in H. Is it correct?
Yes, sir.
Yes, sir.
Intersection is there. Similarly, up to so on. H intersection first derived subgroup of G, that is G dash. Okay, it is contained in H. High intersection is the okay, that's why here all the terms are contained in H. That means all these are, we have to prove that these are the all the normal subgroups of each other. Okay, so this one is subgroup of this one, normal subgroup. This one is normal subgroup of next one. Okay, this one is the normal subgroup of this one. Okay, with abelian factor. We show that this is abelian factor, then this series is solvable. Okay, any doubt?
No, sir.
No, sir.
No, sir.
We know that what is G raised to I plus 1. Okay, I plus 1 derived subgroup of G is normal in G raised to I. Look at here. Here the G raised to G2, that is second derived subgroup of G is normal subgroup of G. Okay, because what? G is solvable group. Similarly, in general, G raised to I plus 1 is normal in G raised to I, where I running from 0, 1, 2 up to n minus 1, not n. n म्हणलं की इथं n plus 1 आला ओके जी रेस टू n plus आहे का आपल्याकडे नाही that's why n I running from 0 to n minus 1. Okay, now consider h raised to I plus 1, that is I plus 1 derived subgroup of h is equal to हा काय अजून केलंय मी h intersection ith derived subgroup of G. Okay, ith derived subgroup of H is nothing but what? Intersection of these two subgroups. Ith plus 1 derived subgroup of G intersection H. That is H raised to I. Ith derived subgroup of H is equal to what? H intersection G raised to I. Is it correct? So here अजून काय येईल मला ith derived subgroup of H is equal to H intersection ith derived subgroup of G. Okay. Any doubt up to here?
No, sir.
No, sir.
No. So this implies H raised to I plus 1, that is I plus 1 derived subgroup of H, this one is normal subgroup of this one, that is H raised to I. Okay, हा जर याच्यात नॉर्मल असेल तर त्याचा इंटरसेक्शन घ्या दोन्ही आहेत सोबत काय येईल दिस इज व्हॉट I plus 1. Okay, and this is what H, that is H raised to I plus 1 is normal subgroup of ith subgroup, ith derived subgroup of H. Okay, any doubt?
No, sir.
कळते का काय सांगतो व्यवस्थित?
No,
We
sir.
know we have g raised to I plus 1 is normal in g raised to I. Okay, ith derived subgroup of G, that is taking intersection with H, we get this one. टेकिंग राईट हँड साईड काय येईल माझा हा, आणि याला काय कन्सिडर केलंय मी? एच रेस टू आय प्लस वन इज नॉर्मल इन एच रेस टू आय. Now let us define the one mapping. Let us define. Okay. Now here we get हा याच्यात नॉर्मल सबग्रुप. ओके, हा ह्याच्या नंतरच्या ह्याच्यात नॉर्मल सबग्रुप. This one is normal in this one. Okay, this one is normal in this one. Okay, we get this one. Okay, now we have to show that this h I plus 1, I plus 1, okay, hi upon hi plus 1. If we show that, we have to show that this series is solvable series. That means normal तर मिळालाय. Now we have to show that with abelian factor. What is abelian factor? This is h raised to I upon h raised to I plus 1. If this group is abelian group, then this series becomes an solvable series. If this series becomes solvable, then H is what? Solvable. Okay. तर त्यासाठी काय करावं लागेल? Let us define one mapping. Which mapping? F. From F is the function from ith derived subgroup of H to ith derived subgroup of G divided by I plus 1th derived subgroup of G. Okay, so now this one is the quotient group such that कसा define केला तो mapping? F of x is equal to x into g raised to I plus. Okay, g by h हा जर तुमचा ग्रुप असेल तर every element of this group is of the form AH or HA, where this A belongs to G. Okay, is it correct? हा H खालचा ग्रुप असाच आहे, आलाय का इकडे खालचा? Yes. And this X belongs to GI. Okay, हा X GI मध्ये आहे का? कारण की आपण हा X तर इथून घेतलाय ना HI मध्ये, इनपुट मध्ये HI मध्ये. I3 derived subgroup of H. But what is HI? Look at here. This is HI, na? This is H intersection G raised to I. Okay, which is contained in what? या दोघांमध्ये छोटा कोण आहे? हा इंटरसेक्शन घेतलाय म्हणजे हा छोटा असेल. ओके, this is contained in G raised to I, that is I3 derived subgroup of G. That means एखादा x जर तुमचा HI मधनं येत असेल तर तो काय होईल? हा x ऑटोमॅटिक GI मधनं येईल. Is it correct?
Yes, sir.
ओके, म्हणजे हा x कुठनं आलाय? Yes, from it is element from G raised to I, that is I3 derived subgroup of G. ओके, नाही तर तुम्हाला घोळ होईल की ते माझा डोमेन आहे एच रेस टू आय आहे. ओके, आणि आउटपुट काय दिसतो? एक्स इंटू जी रेस टू आय प्लस 1. तर हा एक्स जी रेस टू आय मधने कसा येईल बाय दिस डेफिनेशन? ओके, तर तो असा येतो एक्स बिलॉंग्स टू एच रेस टू आय. दॅट मीन्स एच रेस टू आय इज नथिंग बट एच इंटरसेक्शन जी रेस टू आय, which is contained in G raised to I. Why? Because this one is smaller. Okay, this one is smaller, H intersection G raised to I and G raised to I. Which one is smaller? This group is smaller. Okay, that means this x belongs to G raised to I. That is f of x is equal to x into G raised to I. Right. F of x is equal to x into G raised to I plus 1. Okay, since for all x belongs to domain, what is domain? Ith derived subgroup of H. Okay, since reason H intersection ith derived subgroup of G is equal to what? Ith derived subgroup of H. It's contained in G raised to I. Okay, that implies if X belongs to H raised to I, that is ith derived subgroup of G. So that implies X belongs to ith derived subgroup of G. Okay, so consequently, we get this X into G raised to I plus 1. This element, what name was a G raised to I divided by G raised to I plus 1. Okay, hence this mapping is well defined. Is it correct?
Yes, sir.
म्हणजे mapping exist होतं
Yes.
कसा? Well defined. Okay, now look at here. But what is G raised to I upon G raised to I plus 1? It's abelian. Is it correct? हा तुमचा ग्रुप कसा आहे? Abelian. Why? Because this series is what? Solvable series, na? This series is what? Solvable series. Solvable series means every factor group here the abelian group. Okay, if you show that this function is onto homomorphism, जर हा फंक्शन जर onto homomorphism झाला तर हा एच आय याला आयसोमॉर्फिक होईल. हा एच आय जर याला आयसोमॉर्फिक झाला तर बाय फर्स्ट फंडामेंटल थेरम ऑफ आयसोमॉर्फिझम व्हॉट वी गेट एच आय अपॉन कर्नल ऑफ एफ इज आयसोमॉर्फिक टू दिस वन ना. इज इट करेक्ट? फर्स्ट लेक्चर. ओके, येईल पुढे कळेल मला कसं. वेट. So this function is well-defined function. Also, let us assume x and y with any two elements belongs to ith derived subgroup of H. Okay, so what is f of x, y? By the definition of f, we get this is x into y into g raised to I plus 1. Is it correct? This is
Yes,
the
sir.
function. Okay. But we know that a b into h is equal to a into h into b into
P
h.
into
Is it
X.
correct? So this is equal to x into g raised to I plus 1. Okay. Into x
Y.
and y into g raised to I plus 1. Ith derived subgroup of g. And that is what f of x into f of y. Hence, we get here f of x into y is equal to f of x into f of y. That means this f is homomorphism. Okay, any doubt?
No, sir.
No. That implies this f is homomorphism of h raised to I onto into sorry not onto into homomorphism g raised to I upon g raised to I plus 1. Okay, म्हणजेच काय? Suppose this one is h raised to I. Okay, ith derived subgroup of h. My function is from h raised to I to this one. What is this one's codomain? G raised to I upon g raised to I plus 1. Is it correct? This
Yes,
function
sir.
f is into homomorphism, not onto homomorphism. Into homomorphism. Into functions आते काय? Suppose x belongs to hi. Into homomorphism. First day, first lecture, second lecture, I think. What is into homomorphism? Range of
Codomain is
f.
not equal to range of F.
Range of f is properly contained in codomain. Na?
Yes.
Yes, sir.
Okay. If function is onto, that means the range is equal to codomain. but here proper subset we get. So माझा एफ ऑफ एक्स कुठे येईल, माझा माझा रेंज सेट कुठे येईल, ह्या प्रॉपर सबसेट, ह्या कोडोमिनचा प्रॉपर सबसेट येईल. ओके, इज इट करेक्ट?
Yes, sir.
याच्या आतमध्ये कुठेतरी येईल, नॉट इक्वल येईल. ओके, मग जो काही जो पार्ट येईल रेंज सेट, त्याच्यावरच तो आयसोमॉर्फिक असेल. आता काय फंक्शन झाला, सपोज दिस वन इज एच रेस टू आय and this is the function, and now my codomain becomes this one only, range set. हा जो काही आलाय ना रेंज सेट एवढाच घेतलाय f of x. आता हा फंक्शन काय होईल, ऑन टू. इज इट करेक्ट?
Yes, sir.
Okay, now we can apply fundamental theorem of isomorphism, homomorphism. What is the fundamental theorem of homomorphism? This h raised to I into upon kernel of f is isomorphic to कोणाला isomorphic असतो, या रेंज सेटला. ओके नाही? सो व्हॉट इज द रेंज सेट? f of h आहे ना, h raised to I. आता हा एफ ऑफ एक्स म्हणजेच काय माझा, दिस इज एफ ऑफ एच रेस टू आय. एक्स कुठून आलाय माझा, इथून येतो. ओके, दॅट इज एफ ऑफ एच रेस टू आय, आय थ्री डिराइव्ड सबग्रुप ऑफ एच. इज इट करेक्ट?
Yes, sir.
ओके, हे स्टेटमेंट तुम्हाला सगळं समजण्यासाठी लिहिले बरं का इथून, नॉट द पार्ट ऑफ दिस बुक. ओके, now here f is homomorphism. F is homomorphism of h raised to I into g raised to I upon g raised to I plus 1. Okay, that means the range set is the proper subset of codomain here. Okay, now further, what is kernel of f? Well, the x belongs to kernel of f. What is the meaning of this one? This implies if we apply the function f on this element x, so we get identity of that codomain. What is the identity of codomain? This is the codomain. What is the identity of this codomain?
G raised to I plus 1.
G raised to I plus 1. Okay, so this is g raised to I plus 1 means I plus 1 third derived subgroup of g. But by the definition of f of x, this is x into g raised to I plus 1, which is equal to g raised to I plus 1. Okay, that implies x belongs to g raised to I plus 1. Is it correct?
Yes, sir.
Yes, sir.
Okay, he implies an implied statement. Okay, why? What is the reason? Since a into h is equal to h, that implies an implied a belongs to h. That means here the x belongs to g raised to I plus 1. Okay, so hence this x belongs to what? G raised to I plus 1. Okay, now what is kernel f? Kernel f हा कोणाचा सबसेट असतो? डोमेनचा. What is the domain? Okay, h आहे. म्हणजे हा kernel of f तुमचा इथे कुठेतरी असेल. This is kernel of f. Is it correct? This is the domain of, sorry, this is the subset of domain. Okay, so hence here we get, look at here, hence here we get x belongs to g raised to I plus 1. Okay, x belongs to जर कर्नल f मध्ये जर असेल तर कुठे येतोय, x belongs to g raised to I plus 1. Look at here, x belongs to kernel of f. But what is kernel of f? Kernel of f is the subset of domain. What is domain? ith derived subgroup of h. Is it correct?
Sir.
म्हणजे हा x माझा g raised to I plus 1 मध्ये पण आहे, x belongs to h raised to I मध्ये पण. Okay, what is h raised to I? H raised to I is the ith derived subgroup of h. Okay, that is हा कोणाचा सबग्रुप आहे? h चा सबग्रुप. ओके, सबग्रुप म्हणजे सबसेट असणार. दॅट मीन्स हा x कुठून येतोय माझा? h मधून येतो. सो दिस इम्प्लाइज this x belongs to g raised to I plus 1 and also x belongs to h. This implies x belongs to h intersection g raised to I plus 1. So this implies x belongs to h raised to I plus 1. Is it correct? What is this one? I. Is it correct?
Yes, sir.
Yes, sir.
So h intersection g raised to I plus 1 is nothing but h raised to I plus 1. जे माझा x कुठे आलाय h raised to I plus 1. So that means this implies kernel of f is equal to what? H raised to I plus 1 is the answer. Okay, he implies an implied statement. Okay. Okay. म्हणजे जर x माझा कर्नल f मध्ये घेतला तर काय येतोय h raised to I plus 1. जर h raised to I plus 1 मध्ये घेतला तर काय येईल हा x माझा कर्नल. That means kernel of f is equal to h raised to I plus 1. Then by the fundamental theorem of homomorphism. ओके, फंडामेंटल थेरम ऑफ आयसोमॉर्फिझम मध्ये तुम्हाला 1 दाखवावं लागेल, ऑन टू दाखवावं लागेल आणि होमोमॉर्फिक दाखवावं लागेल. बट हे फंडामेंटल थेरम ऑफ होमोमॉर्फिझम त्याच्या रेंज सेटवर तो आयसोमॉर्फिक असतो. ओके, इफ द फंक्शन इज नॉट ऑन टू देन इट इज आयसोमॉर्फिक टू रेंज सेट. दॅट इज हा जसा रेंज सेट दाखवले की नाही याच्यावरच तुमचं काय असतंय आयसोमॉर्फिक असते. So then the fundamental theorem of homomorphism of group, we have the domain upon kernel of f, it's isomorphic to range set. What is the range set? Not codomain, okay, range set f of h raised to I. Okay, हा सबसेट असे नका ह्याचा g raised to I upon g raised to I plus 1. Okay, so here h raised to I plus 1, sorry, h raised to I. What is kernel f? आता घेतलं I h raised to I plus 1. Okay, it's isomorphic to f of h raised to I. Is it correct?
Yes, sir.
Okay. This is what h raised to I. Okay, my dog. This one is the function. What is codomain काय होतं तुमचा g raised to I upon g raised to I plus 1. इथे कुठेतरी तुमचा काय येतो हा सबसेट f of h raised to I. Okay, now look at it. f of h raised to I. Okay, if this one is group, this one is group, and f is the homomorphic function. The result पण पाहिला. Then the image of this group h raised to I, that is f of h raised to I is subgroup of what? G raised to I upon g raised to I plus 1. Is it correct?
Yes, sir.
Now, this g raised to I upon g raised to I plus 1 is abelian. Okay, why? Because G is the solvable group. That means there exists a sequence that solvable. There exists a solvable series with abelian factor. Okay, solvable series. Okay, that means G is G raised to I upon G raised to I plus is abelian. And every subgroup of abelian group is abelian group. So this is the subgroup of abelian group. Hence, this is again abelian. हा जर abelian झाला, but which is isomorphic to what? हा कोणाला isomorphic आहे h raised to I upon h raised to I plus 1. So this again abelian. Is it correct? काय सांगितलं कळालं काय?
Yes, sir.
कसा आला हा abelian कसा आला? Okay, पहा नीट. हा स्टेटमेंट नीट लक्षात ठेवा. h raised to I upon h raised to I plus 1 is isomorphic to f of h raised to I. Okay, but f of h raised to I is subgroup of codomain. Okay, subgroup of codomain. What is codomain? G raised to I upon G raised to I plus 1, which is abelian. Okay, that means f of h raised to I is also abelian. Why? Because the subgroup of abelian is abelian. Okay, so which is, but this one is isomorphic to whose? H raised to I upon h raised to I plus 1 is also abelian. Okay, what is the reason? Because h raised to I upon h raised to I plus 1 is isomorphic to f of h raised to I. Okay, now look at here. We get h raised to I plus 1 is normal in h raised to I, and this is abelian. Is and this group is abelian. Hence, what is hi? This one. This one is what? Hi. Okay, that means this series is what? हा तुमचा not only contain हा तुमचा subgroup येतो normal subgroup. Okay, with abelian factor. That means this series equation 1 is solvable series. Okay, so that implies 1 is solvable series. Any doubt?
No, sir.
Okay, so by the way, so any subgroup of solvable group is again solvable. That H, that implies H is solvable group. Okay, काही डाऊट असतील तर विचारू शकता. Any doubt?
No, sir.
Our questions are 32. Now the next theorem is homomorphic image of solvable group is solvable. What is this theorem? Suppose the G is the solvable group. Okay, solvable. And if there is a function f from G to, suppose this one is G naught is there, and f is suppose homomorphic. Okay, I don't know whether this function is onto or onto into काय आहे मला माहित नाही, but this f is what? Homomorphic. What is the meaning of homomorphic? It preserves the operation ना, म्हणजे जो काही स्ट्रक्चर ह्याचा असेल तो स्ट्रक्चर ह्या कोडोमिनचा असतो. Is it correct?
Yes, sir.
Okay, so here the G is solvable and the homomorphic image of this group, that is f of G, हा कोणाचा सबसेट असेल? इथे कुठेतरी असेल. Okay, range f of G. Then this becomes again solvable. Okay, f of G म्हणजे कसा असेल? Solvable. Okay, and the next theorem is homomorphic image of solvable group is solvable. Homomorphic image of solvable group is solvable. Okay, okay, good. Let G1 and G2 be two groups. Be the two groups. Okay, such that let there exist a such that there exists a onto homomorphism. Okay, onto homomorphism. Okay, what is f? F is the function from G1 to G2 such that the function is onto function. That means f of G1 was a पूर्ण G2. Okay, why? Because the function is onto. That means the range is equal to codomain here. Okay, any doubt?
No, sir.
No, sir.
there exists a function f from G1 to G2 which is onto. Now consider this G1 and G2. Now this G1 is solvable. We have to prove that what? We have to prove that G2 is solvable. Okay, and G1 तुमचा solvable आहे. G2 तुम्हाला solvable दाखवायचं. Okay, that is image of G1 is solvable. कळते कसं आलं का?
हो सर.
Wait. Theoremचा अर्थ समजत नाही. Homomorphic image of solvable group. Now this is F. This F is what? Onto homomorphism. What is the homomorphic image of, and G1 is again, let assume this one. G1 is solvable. Okay. Now the homomorphic image of solvable group, that is, this is homomorphic function of solvable group is solvable. That is, we have to prove that f of G1 is solvable. But this function is what? Onto function. That implies f of G1 हा तुमचा range set. Range set is equal to codomain. That is G2 is solvable. So we have to show that G2 is solvable. Okay, now it is clear.
Yes, sir.
Now consider this U1 is equal to A, B, A inverse, B inverse, such that this A and B belongs to G1. Okay, or commutator set of G1. Okay, this is nothing but commutator set of G1. And what is U2? U2 is nothing but X, Y, X inverse, Y inverse, where X and Y belongs to G2. Commutator set of G2.
G2.
Okay. Now given that F is onto homomorphism. Onto homomorphism. Okay, म्हणजेच काय ऑफिस onto homomorphism म्हणजे range is equal to codomain. Okay, now look at it. This one suppose G1 हा तुमचा U1 असेल commutator set. This one is G2. Okay, and this is U2. This is the function f. Okay, so look at here. For f is onto homomorphism, then for any x and y belongs to G2, there exist L and M. Okay, there exists L and M. Okay, belongs to what? G1, such that, okay, where x and y, this is suppose x and y. कुठेतरी आहे म्हणजे आतही असतील बाहेर असतील, I don't know. Okay, for this x and y we get range is equal to codomain असल्यामुळे काय होईल, प्रत्येक इमेजला इथे काय असेल, माझा प्री इमेज असेल. इज इट करेक्ट? या पॉइंटला इथे असेल, या पॉइंटला इथे कुठेतरी असेल. Okay, suppose this is L and M. Okay, so for any xy belongs to G2, there exists L and M belongs to G1, such that this f of L is equal to M, and sorry, f of L is equal to x. No? F of L is equal to x, and f of M is equal to y. येतोय का? y वर जर मी f अप्लाय केलाय, okay, then it becomes y. F of M is equal to y and f of L is equal to L. Is it correct? F of L is equal to x. Okay?
Yes, sir.
Now, what is U2? U2 is equal to x, y, x inverse, y inverse, such that x and y belongs to G2. This is the set. Okay, now what is x? F of L. What is y? F of m, okay, into f of L inverse into f of m inverse. Okay, where L and m belongs to G1. Okay, and f of L and f of m belongs to Nitin. कुठे येतील f of L and f of m?
G2.
This belongs to G2. Okay, now this is the definition of U2 now. Okay, that means U2 is nothing but IL. This is M. This is L inverse. This is M inverse. L and M belongs to G1. Okay, तर फक्त U1 मध्ये काय आहे तुमच्या A, B, A inverse, B inverse. इथे काय आहे F of L, okay, F of M, F of L inverse, F of N inverse, M inverse. L, M belongs to G1. That means U2 is nothing but F image of U1. Is it correct? जर मी इमेज ऑफ U1 घेतला तर काय येईल U2. पहा, this L belongs to U1, this M belongs to U1. Okay, L inverse. Okay, any doubt?
Sir, they
कळालं
repeat झालं.
नाही? Okay. U1 मधले सगळे इमेज कसे आहेत? U1 मधले पॉइंट कसे आहेत सगळे? What is U1? A, B, A inverse, B inverse, where A and B belongs to G1. हा L कुठे आहे? G1 मध्ये. हा M कुठे आहे? G1. ओके, हा L इनवर्स कुठे आहे? G1. This M inverse belongs to G1. म्हणजे तुमचा एलिमेंट कशा फॉर्ममध्ये आहे? या फॉर्ममध्ये. म्हणजे या U1 ची F इमेज घेतल्यानंतर काय होतोय? U2 तयार होतोय. कळतं का पुन्हा? What is U2? U2 is equal to F of L into F of M into, this is F of L inverse आतल्या. Okay, you know that F of X bracket inverse is equal to F of X inverse. Okay, हे BSc ला झालेलं आहे, माहिती आहे ना?
Yes, sir.
This is into F of M inverse, where L and M belongs to what? G1. एवढंच लक्षात ठेवा, हे नको सांगू. ओके, म्हणजेच काय? L, M, L inverse, M inverse, L, M belongs to G1. म्हणजे U1 च्या एलिमेंटवर F अप्लाय केला. Is it correct?
Yes, sir.
Okay, that is F of U1. So U2 is equal to what? F of 1. Is it correct?
Yes.
Yes, sir.
Yes, sir.
Image of U1 is nothing but U2. So this is what is U2 is equal to F of 1. Okay, so this implies U2 is equal to F of U1. The smallest set containing, smallest group containing U2 is what? Derived a subgroup of G2. Okay. U2 is what? Commutator set. F of U1 again commutator set. Okay, so what is U2? U2 is nothing but the smallest group containing U2 is nothing but derived subgroup of G2. Okay, दोघांचा smallest subgroup आहे. That is smallest इथं काय येणार मग? F of G1 dash. Is it correct?
Yes, sir.
Yes, sir.
The smallest group containing U2 is nothing but G2 dash. That is derived subgroup of G2, which is equal to smallest group containing U1. That is F of G1 dash derived a subgroup of f of g. Okay, since this g1 dash is generated by u1 and g2 dash is generated by u2. Okay, म्हणून मागच्या लेक्चरला अटेंड राहायचं आहे ऐकायचं. Okay, so this is for first one. In general, so in general we can write f of nth derived subgroup of g1 is equal to what? Nth derived subgroup of g2. Okay, first in general we can write nth derived subgroup of g1, image of nth derived subgroup of g1 is equal to nth derived subgroup of g2. But g1 is what? Homomorphic. Okay, g1 काय तुमचा homomorphic. Sorry, solvable group. Is it correct? We have to show that we have to do that g1 is solvable. We have to do that g2 is solvable. Okay. By the last theorem, last previous theorem, if g is solvable, then g raised to n is equal to what?
Singleton E.
Singleton e. Okay, which is equal to g2 raised to n, nth derived subgroup of g2. Okay, if f is homomorphic, then identity maps to, suppose this is the identity, e1 is the identity of g1. Okay, identity कोणाला मॅप होते? Identity under homomorphism, onto homomorphism, identity ला मॅप होते. What is the identity of g2? G2 raised to n. That is nth derived subgroup of g2. Okay, where e2 is identity of g2. Okay, so from this one, this implies g2 is homomorphic image of g1, and this implies g2 is solvable. Okay, when we get g2 is solvable, if and only if statement पाहिला आपण, g raised to n is equal to singleton असेल तर if and only if g is solvable. Okay, here the condition satisfy this one. g2 raised to n is equal to singleton e2. That is g2 is solvable. Any doubt or clear?
No, sir.
No, sir.
So एखादा function, एखादा homomorphic असेल, if there exists a function such that the function is homomorphic onto homomorphic, then that codomain is again solvable. Okay, that is the homomorphic image of solvable group is solvable. Okay. And the next is corollaries there. Okay, any quotient group of solvable is again solvable. The next point is corollaries there. Any quotient group. Any quotient group of solvable group is solvable. Okay, that means what? G is solvable, suppose. Okay, that means g raised to n is equal to e. Okay, and derived subgroup of g is याचा तुमचा कोणताही सॉल्वेबल ग्रुप घेतला. सपोज h is the normal in g. This h is normal in g, and if you define the quotient group hg by h, then this quotient group is again solvable. Okay. Okay, proof right? Let छोटा दोनों स्टेप let G be a group and n is what? N is normal subgroup in G. Okay, suppose this one is G and this one is what? Normal subgroup n. Okay, that is N is normal to G. Okay. Then the mapping F from G to G by N is what? That is. ऐसा डिफाइन कर लें the function f from G to G by N defined by defined by f of small g, okay, where small g belongs to capital G, okay, which is equal to n into g for all small g belongs to capital G is onto homomorphism. Is it correct?
Yes, sir.
कसा लिहिला मी ऑन टू होमोमॉर्फिझम डायरेक्ट ते आत्ता तो केला होता जर फंक्शन जर असा डिफाईन केलेला असेल तसं ठीक आहे एफ जर एखाद्या ग्रुप पासून कोशंट ग्रुपला डिफाईन केलेला आहे एफ ऑफ एक्स इज इक्वल टू जी एक्स किंवा एक्स ची काही असू ओके इथे काय होता इथे काय आहे जी आहे इथे एन आहे इकडे जी आहे ओके इथे काय होतं एन इंटू जी ओके हा जर एक्स इथे घेतला तर जी एक्स भेटला एन इंटू जी असा डिफाईन केला तर तो ऑनटो ओके ह्याच्या पुढे कधीही जर हा थेरम हा फंक्शन असा डिफाईन केला असेल तर त्याला डायरेक्ट म्हणणार आपण ऑनटो okay if f is the function from g to g by n such that f of g is equal to ng then the function is onto homomorphism okay so no need to prove the again येईल प्रूव्ह करता पण आपल्याला काही गरज नाही कसं होईल करता f of x y by the definition of f of x y what we get this is n x y which is equal to nx which is equal to ny okay which is equal to f of x into f of y okay तो फंक्शन काय झाला होमोमॉर्फिक झाला ऑन टू कसा प्रूव्ह करणार for any nx belongs to g by n there exists हा x कुठून येतोय x belongs to g okay hence this f is what onto for any element of codomain we get element in domain hence the function is onto okay so here there no need to prove once again so what we have here this is ontomorphism okay thus g by n is what g by n is homomorphic image of g is it correct g by
Yes, sir.
n is the homomorphic image कोणाचा image या g चा okay so hence here g is solvable G soluble which is given to us. That means the homomorphic image of G, that is G by N, is solvable. That means any quotient group of solvable group is solvable. Is it correct?
Yes, sir.
Yes, sir.
Any doubt?
No, sir.
No, sir.
Okay, wait a minute.